So on to lesson 2 in chapter 3, we're going to work on multiplying decimals for this lesson. So at the end of the lesson, we should be able to multiply a decimal by a decimal. So we're going to look at doing this with a number line, and then a different method where we multiply vertically, and then another method where we multiply mentally, and then I'll show you a method that I often use, which is using the base fact. So we're going to do a couple of those different methods. So basically, we're going to call this method number 1, which is using a number line. So we can multiply the tenths place by a whole number using a number line. So the tenths place would have those two place values with the decimal point in between. So this necessarily doesn't have to have a digit there, but this would have to be like a number, like 1, 2, 3, 4, 5, 6, 7, 8, or 9. So if I multiply an example such as 3 times 2 tenths. So if I start here at 0, so if we say this is 0 on my number line, and I'm going to multiply 3 times 2 tenths, I'm going to take 3 jumps of 2 tenths. So if this is 1 tenth, that would be 2 tenths. So the first jump right here, I make it 2 tenths. So that's 1 jump. And then I make it another 2 tenths. That's another jump. So I'm kind of making tally marks up here. So when I make it another jump, 2 tenths plus 2 tenths is 4 tenths. And then I have how many more jumps to go? 3 would be 3 tally marks, so I have 1 more jump. And that would make it 2. 4 plus 2 is 6 tenths. And that's 1 more jump, so I made it 1, 2, 3 jumps. So you could count it 1, and then 2, and then 3. However, sometimes that can be confusing when you get into higher level problems and you're trying to visualize it, because somebody coming along might think that this is 1, and this stands for 2, like you jump 2. And then this would stand for 1, 2, 3 jumps, when really it's only 1 jump each. Okay? I could also do this with 100th place. So down here I could multiply 3 times 2 hundredths. So that would be a whole number with 2 place values behind the 0 times the whole number. So if I start again at 0, now I'm jumping by 2 hundredths, which if I looked up at this number line here, 2 hundredths would be like so tiny that I couldn't even see it. So I'm going to use that same jump to show 2 hundredths. I'm just going to number my number line differently. So now I'm going to say that that jump represents 2 hundredths. And I'm going to jump 1 time there. My next jump wouldn't be to tenths now. It would be 2 hundredths plus 2 hundredths is now 4 hundredths. That's 1 jump. And then my next jump is still 2 hundredths. So 4 hundredths plus 2 hundredths is 6 hundredths. So what you should see is that 3 times 2 hundredths is 6 hundredths. I landed on it right there after 3 jumps. Whereas 3 times 2 tenths is 6 tenths. So I can find that by my number line. I can find that again by my number line right here. So that's method 1, using both tenths and hundredths. Okay. On my paper, I'm going to use a different color to show you method number 2, so you don't get confused. So method 2. is going to be where you're multiplying vertically. So we're going to write vertical multiplication. So using this same problem, I'm going to multiply 3 times 2/10. Now in previous grades, you might have had your teacher tell you that you have to put the bigger number on the top of a multiplication problem. And technically what they were trying to tell you is to put the number with more digits on the top. And typically, usually, the number that's bigger has more digits. But when we start to multiply by decimals, that's not always going to be the case. Before you include decimals, then obviously the number that has more digits will be usually the bigger number. Okay? But when we start to include decimals, like you can see here, 2/10 has more digits than 3 does. So we're going to put 2/10 on the top, and we're going to multiply it by 3. What you'll see is that we do not have to line up our place value when we multiply by a decimal. We do have to line up our place value when we add by a decimal. So if this was 2/10 plus 3, I would have to do 2/10, and then I would have to add the 3 underneath the 0 because it's 3 whole numbers and this is 0 whole numbers. I could put a placeholder 0 in and then add. So when I add or subtract, I have to line up the decimal. When I multiply, I do not. Okay? Then all I'm going to do is multiply like I always do. So I'm going to take 3 times 2, and it is 6. Technically, what I just did is I took 3 times 2/10, which is 6/10. Then I'm going to take 3 times 0 ones, which is 0 ones. Okay. Now that I'm done, I don't have another place value to go over to, so I don't need to add a placeholder 0 and then multiply again. Now I'm going to take this little space over here, and I'm going to ask myself how many decimal places in is my decimal point. And the answer is my decimal point is 1 place value in from the right. So I'm at the far right here, and I count 1 decimal place over. So I'm going to put 1 here. Is there a decimal point in 3? There's no decimal point to the left of it. Technically, there would be a decimal point here, which is on the right. So it's 0 from the right, because that is the far right. So, and then I'm going to add 1 plus 0, which is 1. And that is how far I'm going to move my decimal point in from the right of my answer. So I have my product, and I'm going to take 6. Here I am at the far right of it, and I'm going to move my decimal point over 1. 2/10 times 3 should be 6/10. You should be able to see that that matches with what we found in method number 1. So if I took 3 times 2/10, that equals 6/10. If I take 2/10 times 3, so I just changed the order of my factors, it still equals 6/10. So that's the commutative property of multiplication, where they can switch the order of. So it's kind of like, here's your parent at home. Now they're driving to work. How long is it? It takes that distance to get there. Here they are at work. Now they're driving home. It takes this long to get there. So either way they go, whether they're going from work to home or home to work, it still takes the same amount of time. Okay, now we're going to move on to method number 3. And this is Reno's way. You can also call it using base facts. Okay, so same problem. If I have 3 times 2/10, I need to find what that equals. Okay. My guess is that if you find a base fact, which is what fact do I know that equals something else I know, you can see that 3 times 2 should equal something that you know. So what does 3 times 2 equal? You should tell me it equals 6, hope. Okay. Now, pretty much all I did right here is 3 times 2. Instead of multiplying this by 2/10, I multiplied it times 10. So I changed my problem and I took 3 times 2 instead. So that means my answer is going to be a multiple of 10 more than what it should be. So now I need to divide this by 10. So I just need to move my decimal place 1 to the right and then put my 0 in the ones place. So still my answer is 6/10. Okay, this is a mental math way of how to solve this problem. So when you look at this, you should be able to quickly see that 3 times 2 is 6 and that there's 1 decimal place in and 1 decimal place in. You can see the same thing when you multiply vertically. 2 times 3 is 6. It has 1 decimal in, so you move the answer with 1 decimal place in. So if we look at our hundredths place, it's the same thing. So if we see method 3, which was the base fact, 3 times 2/100. So the base fact would be 3 times 2, which is 6. And then this is 2 decimal places over. So I go 1, 2 decimal places over, and then fill in my placeholder zeros. So 3 times 2/100 should be 6/100. If I do method 2, that was the vertical multiplication. 2/100 times 3, because 2/100, although it's not bigger than 3, has more digits. So 2 times 3 is 6. 3 times 0/10 is 0. 3 times 0 is 0. Then I can say that this is 2 decimal places over. And count it right there, 1, 2. This has 0 decimal places from where the decimal place would be from the right. So 2 plus 0 is 2. I move my decimal place 2 over from the right. So my answer is 6/100. I can also do this and I can multiply tenths by tenths. So I can think of this, my method number 1, would be thinking of it as a fraction. So if I had 3/10 times 2/10, visually I could see this as 3/10 times 2/10, and I would just multiply across. So 3 times 2 is 6, don't add them, and then 10 times 10 is 100. And then since it was written as a decimal, yes, I could leave it as a fraction, but I need to change this back into a decimal. So if you're trying to solve from a decimal, your answer should be in decimal format. Just like if you started with a fraction, your answer should be in fraction format. So 6/100, if you read that, you should be able to rewrite it as a fraction. This is the tenths place, this is hundredths place. So you put the 6 in the hundredths place and then make some placeholder zeros backwards from that. Method number 2 would be to multiply vertically.